Yeah. So I'm actually I'm recording this session also even. In the last session, like we saw a few details about like where exactly the foreign key relationships are stored, and in case of like inserts, in case of foreign key relationship, how this index seeks are happening for checking the constraints, all that information. Along with that, like we also saw like covering indexes. So a covering index is nothing but like I'm sharing my screen. So are you able to see my screen? Yeah.
Yeah.
Yeah, I started sharing my screen. No, okay, so basically, like this is the syntax for non-clustered index. So usually, what we do is like, so if we want to create an index, non-clustered index on display name, so what usually we do is like, so we specify like non-clustered index and then the name of the index and table name and what column it is supposed to be, right? So this is how like we actually create a non-clustered index. So one issue with this particular non-clustered index is that, so when we actually try to query, so basically like let's say like I wanted to query all this information like location and then a is also along with display name. um, so along with display name I wanted to query these details. So in that case, like previously what used to happen is like so, mm, so previously, like what used to happen here in this case is like, so when we don't have like covering indexes, so this query actually does like an clustered index scan. And the reason for clustered index scan is that is because, so this index, like this clustered index, non-clustered index, it already had like this column like display name, but in order to fetch these details like location and age details, so it is supposed to actually go back to the clustered index and get those details. So in that case, like what SQL Server it does is like, so it makes use of statistics. We already saw what statistics are in previous sessions. So it makes use of statistics, and then using those statistics, so it actually determines, okay, so whether I need to, so whether it is optimal to make a like non-clustered index seek, or it is better to do a clustered index scan. Okay, so based on the amount of data that it is actually retrieving, I'll also, yeah, let me, so in this case, like what happens is like, so I already have like a covering index on these three columns: display name, location, and ace. So that is the reason why like it is making use of this idx display location and then location ace index. So it is making use of this particular index which already has these columns included. So what this actually means is like, so the leaf level pages along with the id column, so my clustered index is present on the id column. So along with the id column, so it also stores this information like location and age information. So that's the reason why like it is actually trying to fetch the data from here itself. Okay, so let me try to do something like this. Okay, and see what exactly happens. So in this case, it is actually making use of my non-clustered index that is created. So in this case, let's see what is actually going to happen. So in this case, like again, like it is actually making a key lookup. So it is actually making a non-clustered index seek, and along with non-clustered index seek, it is actually making a key lookup for clustered index. So the reason why it is making a key lookup for clustered index is, so I'm just trying to fetch other column values, right? So along with display name, location, and age, I'm also trying to get other information, so like about me, creation date, display name, ports, all this information. So in order to get that information, so it is going for a key lookup with the clustered index. So why it is actually going for a key lookup and getting data from clustered index? So because like whenever we create a clustered index on a table, so the entire table data, it sits in the leaf level pages of the clustered index, and there is no other place where the data is actually stored. So this is the only point where data is actually stored. um, okay, so any questions? So in the previous sessions.
Right. Somebody's
Uh,
gotta be a little bit more participative, please. Yeah, funny. You get that privilege. So I'm gonna start picking up people so that it can be a little bit more interactive.
Yes.
Funny and Nayak for this session with me.
Okay.
Yeah, yes.
Yeah, yeah, Pawan, no questions. But when we discussed on joins in the previous session, like in
mhm,
order to make a foreign key relation, we need to have a primary key or some key, right, on the table on the column.
mhm.
So while checking that, without creating any foreign key, I just made use of a join. So in
No.
that case, it is doing the complete table scan. Once I have created a key and a like made a relation, created a relation, then it has again jumped to this indexes and it skipped the whole table scan.
Okay. So I didn't actually get your question for me.
So in the last session, we were discussing in order to have a relation like some foreign key relation, we need to have an primary key or some unique key constraints on that column, right?
Mhm.
So if not, it won't allow us to create that key relation between two different tables, right?
Tables. Yeah.
So yeah. So with what I did was like without creating these primary keys, I
Mhm.
tried to make a join even without a foreign key also. So
Okay.
at the time, so it was like it did a whole table scan.
Okay.
So that's obvious, right? As there is no index and all, so it completely traverses the whole table.
Okay, so maybe like I'll take that as another use case because like you see like we have something called as nested loops, and also when you do joins, so basically like it actually takes like two different tables, right? So maybe like in your case it is department table and employees table, and usually like department table will have less number of rows, and then employees table will have more number of rows, right? So for each item in the upper table, like so what SQL Server usually does is like so it will actually take the upper table like base table. So for each row in the base table, so it does like it loops through the entire table, like so for the bottom table
Okay.
kind of thing. So you can actually see number of rows, right? So in that case, like you'll be having more number of rows, right? It will be a combination of like let's say like you have like two records in departments table and then five records in employees table, so it is something like 2 into 5, maybe like 10 rows, right? So that we can take as like a separate session. So basically like okay, so or we can have an offline discussion. Okay.
Okay. Yeah. Yeah. Apart from those, I don't have any questions
Okay.
in the
Okay.
last session.
So in this case, like we saw, so basically we saw what covering indexes are actually. So basically what we can do is like, so along when creating the index, like we can actually include the column data, whatever column data we wanted to include. So this way, like this actually helps in reducing the number of calls. So basically like I'll also show you something like this. Set statistics. Okay, so I'll just show you like how many rows are actually page reads like we'll have in this case. So this is the execution plan. It is actually doing index seek on my covering index. So covering index is nothing but like it is a non-clustered index where we include like few extra columns which we wanted to have. So in this case, you can see like the number of logical reads are like 1165 only. But let me add like few more items like in I'll do like select start, so and we'll see like how many logical reads we'll have. So this time like just because like I included star, so I got like more number of logical reads You can see. So this time it is like all 7,405 record logical reads. So one logical read is nothing but like it is actually reading one 8 KB page. So this is actually reading like 74085 into 8 KB of data. Okay. And the execution plan, if we see this time, so it actually went for clustered index scan. So in my previous case, it went for like clustered index seek on this particular covering index, but just because like I added star, so it actually went for like clustered index scan on clustered index scan. So this is actually reading the entire table data. Okay. So that's the advantage like having covering indexes. So more often, like let's say like we have tables where like we read these columns more often, so we can actually have like a covering index on that particular on those columns. Okay. So that is covering index. And now let's see another type of index. So in this case, like we actually created an index on display name, but we included location and ACE. So when we say include location and ACE, what it is actually doing is in the leaf level pages, along with the display name and then clustered index key, it is also adding data that belongs to these items like location and ACE. So there are like other types of indexes. What we can do is like we can also create like indexes on multiple columns. So this let's say like I'm just creating an index on display name, and then I'm also creating creating an index. I'll create an index on views. Okay. Okay. So this way, like I'll just try to create an index on the views, index on two different columns, display name and then views. Okay, so an index got created on these items, and you can see like the number of logical reads are like 7404. Even at the time of creation of an index, like it is actually doing like, so you can see the execution plan. So it is actually doing a clustered index scan. So it is reading data from the clustered index, and then it is actually sorting. Sorting is based on these items, like I just specified, like display name ascending and views ascending, right? And then finally, it is actually creating a non-clustered index and inserting data into this particular non-clustered index. Okay. So now, okay, so now we'll see like how this non-clustered index, when does this non-clustered index actually come into picture? Okay. So what I'll try to do is like, so I'll try to have a query. Select start from users, where views less than 100. Okay. So let's try to execute this particular query. So what do you think? Like, do you think like this particular index will be used here? So this is the index which I created, and I'm just having like a where clause on views and then 100 views less than 100, or at least like views equal to 100.
Okay, and so it will use that index and will do a key lookup.
I think it will use that index because the star include that display name.
Okay, so let me do like id comma views. So in this case, so let's actually see what is actually going to happen here. Like, okay.
Okay.
So let's see the execution plan. So it is actually doing like non-clustered index scan on these items. Okay. So this is doing a non-clustered index scan. Okay. On this particular index. Now. So I'll also add like display name. Okay. So in this case, let's say like I wanted to have like I'll just have like where clause and display name equal to so and so. Okay, so in this case, let's see what the execution plan actually looks like. So you can see like, so it is actually making an clustered index seek on the new index which we created, IDX display views. So it is actually seeking the data. Okay, so let's actually see what all the other indexes which we have. I'll try to delete other indexes which I have. Okay, so this time I have only two indexes. One is this index, and the other one is like clustered index. Okay, so this time, like when I say, so let's see like what the index actually looks like. Okay, so what the execution plan actually looks like. So in this case, it is actually the execution plan is like index seek, right? Okay. So this is how like the index seek. So it is actually doing an index seek, and if I add like an extra condition on top of it, so even this does an index seek. Okay, so when I simply have like views equal to 100, so in that case, like it is actually doing like index scan. Okay, so you see these items, right? Now let me try to do a small thing. I'll just reverse these order. Okay, display name and index. So view, I'll put it as a first item, and then this is my second item, display name. So I'll drop this one. So I'll create this one. So index got created. Now let's see what the execution plans looks like. Okay. So previously, like when we had display name equal to so and so name. So in that case, what's the execution plan in that case?
When display name is good, it is seek, index seek.
Index seek, right? So what do we expect now?
So now it will be scan, non-clustered scan.
Okay, so any reason?
Yeah, because first we are sorting based on views, so the display name will be in the second position, right? So it should again check for remaining things.
Mm-hmm. So
the whole table.
So in this case, it actually doesn't like index scan. So in this case, so even though it is making use of this clustered index, non-clustered index, so it is not actually doing like a seek. So that is because, so if we see the root level page, so if we see the index architecture, let's see the index architecture. So hope I think like everyone got the difference. So previously, like when my order is something like this, display name and then views. So, and when I executed the same query, I got like, so index scan. So, but when I change the order, like this time, like I'm getting index scan. So previously I got like index seek, and now it is index scan on the display name. So now let's see like what this actually does. So previously, like when I did a where clause on view equal to 100, so at that time, like it did like index scan. So we'll see like what it does in this case. So now it is actually doing index seek. So even the order of this particular columns in the non-clustered index, so it actually matters. So what usually people think is like, so usually like they can actually create a non-clustered index on multiple columns, and even if the first even what they assume is like, so it has like 4 or 5 columns, and out of these 4 columns, if I try to do a where condition on one of those columns, then we assume that so the index seek actually happens, like it actually makes use of this index, but that is not the case ideally. Okay. So more difference, like it is actually doing an index seek, and then it is actually going for clustered index key lookup. So the same thing what we'll do is like, so it actually does an index scan in this case. So the number of pages. So here in this case, it is the logical reads are 1 to 96. And previously, like when I had this item, like it will be number of the logical reads will be very less. So I'll just show you the example with the same query. So this one, right? So first display name and then views. Okay. So in this case, let's see how many logical reads we'll get. So this time we got only 6 logical reads. See, that's the difference between like that is where like the order of these columns when we create the non-clustered index, how it actually impacts. So any questions on this?
Yeah, Pawan, one thing.
Okay.
Okay, so previously we used it to include the columns, and now we are mentioning them in the sorting order itself. So that what is the main difference of them? So when we include,
let's see like how the index actually looks like. Okay. So let's start from system index. Just a second. So we saw some of these queries in previous sessions, so not repeat. So this is the index ID 4, and then users. So index ID I'm looking for is 4. So what's okay? So let's execute this. So this is the root level page, and these are like first intermediate level pages, and then these are all like leaf level 0th level pages. Okay. So first let's look at like second level page and how the data actually looks like. So this is the page ID. So I will be doing like DBCC pages, and I'll just pass this page ID here. So let me execute this. So we can see like how the data actually looks like. So we created an index on display name and then views, right? So you can just see like it is actually containing display name, views, and then ID. So ID is nothing but like clustered index ID. So previously, if you remember, like the root level pages, they didn't actually contain included columns. Okay.
Oh, yeah.
So only the leaf level pages of the clustered index, so they actually contain like these items like included column values. But here in this case, so it actually contains both these values like display name and then what are all the columns on which we created the index. Okay.
Okay. Okay.
But the point to note here is like, so let's say like even though we have a non-clustered index on 10 different columns or 5 different columns, and it actually does an index seek on the first column only. Okay. So in order to do the seek, so we need to include all those column values. So let's say like I have like 3 different columns here, like some ABC and then XYZ. So in order to have like clustered index, non-clustered index seek, so either we need to have like where condition on views, or views display name, or views display name ABC, or views display name XYZ. Okay. So that is the order. So it is not something like a where condition on ABC doesn't actually do an index seek on this particular index. And at the same time, like a combination of where condition on ABC, XYZ also, it will not do an index seek. Okay.
Okay.
Uh,
One question.
yeah.
So you have index on both columns, use and display name.
Yeah.
So you are in the query, you are using display name equals to something. Okay. So
Yeah.
now it will don't do the seek and it will do the scan.
So 1 second, like I'm not exactly sure which one I executed. So I'll try to delete this one and I'll just create
Okay.
so that like I'll get clarity. Okay, so I'm just dropping this index. So this way, like when I execute this query, okay, this index. Okay. So I executed this index. Okay.
Okay. Now in the select in the where clause, put views equals to something. Okay. So
End
search
view?
with views,
End,
not end, not
okay.
just only use view.
Okay. So this one, right?
Right. That one.
So I'll also not include any other columns. I'll just have like only indexed columns. Okay.
Okay.
Yeah. So I'll just execute this.
Okay. Okay. Is it it do a scan, right?
Yeah. So it will actually use this index, but it is actually making a scan on the index. Okay.
Okay. So now in the where clause, can we use something like end display name equals to display name?
Yeah. So when we use like end display name equal to display name, in that case, it will make use of index. It will do an index seek. It will do an index seek.
Okay. So my point is, can we use display name equals to display name?
Display name equal to display name?
Yeah. Will that possible?
Not really sure. Never tried this. Let me check. Yeah. So even in this case, so it is actually doing like scan. So that is because like for each and every display name in that particular table, so we are actually checking, okay, so whether the view is equal to 100 or not, right? So in that case, like what SQL Server actually thinks is like, okay, so instead of me doing a seek, seek is nothing but like it will actually traverse from the root level nodes to the child intermediate level nodes and then the leaf level nodes. So there will be like extra overhead, right? So unnecessary reading of like index level pages. So what it thinks is it is actually reading only the leaf level pages of this clustered index scan. So in this case, like if I do star, so I'm just assuming, so this will actually do a clustered index scan. Let's see. Just yeah, okay. So even in this case, it is actually doing index scan and then it is actually doing a key lookup. So what it actually does is like it actually makes use of these statistics. So before actually
so my point is, so we have tables which have multiple columns, okay, and based on the queries, sometimes we use 3 columns and sometimes we use 2 columns, sometimes we use 4 columns in the where class. Okay. So now, I mean, what is the best way to create index in there, using 4 columns or using 2 columns? So based on my analysis, so nothing worked properly. So ultimately what we ended up is creating multiple cluster index, non-cluster index, one with 4 columns, one with 4 columns, like that.
Okay.
So just checking if we have any better way to avoid that, to avoid creating multiple non-cluster indexes.
Yeah, so basically it all actually depends upon the number of queries and then the number of items. So let me take one example and I'll just try to answer your question with that example. Okay. So let's say like I have like views display name and along with that I also have location and age.
Okay.
So this I just plan to create a non-clustered index using all these 4 columns. Okay. But out of 10 queries, 9 queries, so they are making use of display name as my where condition. Okay. So out of 10 queries, 8 queries are using display name as my where clause.
Okay.
So majority. So in that case, like what I'll try to do is like, so I'll just try to create an index on display name and I'll just include these columns.
Okay, yeah, got it.
That is like
Uh,
covering index.
Okay, so the covering index, will that be applicable in where class as well, or just to in the
No,
select only?
so covering index, what the advantage of covering index is, so in this case, so for display name, it is actually making like, it is making use of clustered index, non-clustered index, right? So if I don't include, so if I just create an index on a non-clustered index on display name alone, and if I try to make use of like views location and then A is in the select clause or somewhere else, okay. So what happens is like, so it is actually making extra calls to clustered index.
Okay.
So the leaf level page will only contain, so let's say like this is my scenario. So if I just do this thing like only in a non-clustered index on display name, so my leaf level pages, what they have is like, so they'll have like display name, along with that they'll have like clustered index ID. So when I do a select clause and then include star or other column names along with display name, so in that case, like in order to fetch those extra columns like views, location, and A's, it actually does like key lookup.
Yeah.
Okay.
So that I got it. So if we add additional condition there in the where clause, display name and additional column there.
Yeah.
So adding a key lookup for that column help in the where clause as well, or just in the select?
So it will basically make use of display name, and then it will filter it will along with that it will use the filter like, okay, so index, non-clustered index.
Okay.
So and then in order to filter the other values, so what it does is like, so it will actually do clustered index, non-clustered index. So let me actually create that. Okay. So let's say like I have this item, I just deleted my index, so I'm just creating my display name. So here like I'm just doing like and views equal to 100. So if I just wanted to have like ID and display name in this case, but here like I have my non-clustered index on display name, so my leaf level nodes will have like ID and display name values, right? So but I also need to filter using this views equal to 100. So this should actually go for like key lookup. So just for like filtering on this views equal to 100, so it needs to get this information like views information, right? So but views information is not present in my non-clustered index, so it is actually making a key lookup.
Yeah. Now if you add that views as a lookup field.
So maybe like if I can add it like so if I just include this views.
Yeah.
Okay. So this time like what it does is like, so it will not do key lookup. So it will simply do an index seek. So because like with index seek, I'm able to get this information like views information also. And if we see the root structure, like I got a chance, right? So select star from sys.index. So I hope like you all remember like how the root level page actually looks for like 2 or more columns. So now let us see for this particular page. This is the root level page. So in this case, like you can see, we have only display name and then ID. Okay. So even though like I included views, so that is not actually present in these index columns. Let's go back to these actual root level pages. I'll just go for one of these root level pages. So here you can see like display name, ID, and then views. So this is a leaf level page. So which actually contains views, which is an included column.
Okay.
Okay. So I think like most of them, they got an idea on what covering indexes actually are and what this include actually. So where exactly this helps us out. Okay. So include is basically used to avoid like key lookups and then key lookups. So basically it is used to avoid like key lookups, and in worst case scenarios, it also avoids us to go for non-clustered index scans also. Okay, so that is where like includes help. And clustered index, non-clustered index on multiple columns, so it acts in the similar way, but with include, so we cannot have like a where clause. So the where clause simply, let's say like I'm just doing like I have like an index on display name and then included on views, right? So this doesn't actually use this index. Okay, it doesn't seek, so it actually does a scan. So it is actually going through the leaf level nodes. Okay, so any other questions?
So will the execution plan will be differ on sorting order, ascending, descending?
Execution plan actually it differs. Yeah, so let me show you. So basically in this case, so what is actually happening, so it is actually doing a scan, right?
Yes.
So index scan. So in this case it doesn't actually help us out. So basically let's say so I have something like order by views, order by ID. Okay, so it is actually using the index scan, but the sort operator you see, so this is actually making use of the sort. So this is actually sorting. So usually like when I follow Brent Tozer's blogs and then articles, so what usually he says is that so SQL Server is not actually meant for doing some of these sort operators. Okay, so that is because, so this is like a CPU intensive task. Okay, so we are not actually fetching any data here. So this is the part where we are actually fetching the data, all the records from the table, right? So
Okay.
here what we are actually doing is like, so on the data which we fetch, so we are performing some sort operation. So sort is actually like, this is a CPU bound operation. Okay, so
Okay.
you can see the cost actually, so it is actually 11% of cost it is actually taking. So so usually like one SQL Server license, so it actually costs like enterprise edition or other editions like so they actually cost like $7,000 or something like that. So basically, okay, so the more number of sort operations or these kind of operations we do on SQL Server, so it actually takes like, it utilizes the CPU amount and other queries, so which are actually getting executed. So if the load on the server is more, so at that time like they have like some impact. Okay,
Yeah.
so the same thing, like it is always better to do a sort in the UI, like in the API layer, like
Oh.
C# or somewhere else.
Yeah. Yeah. Okay.
So
Okay.
because like
Got it.
because like the SQL Server like licensing, so it is actually dependent on number of cores.
Okay.
So per core, like it costs actually $7,000 or something like that. So whereas like if you spin up like an AWS instance or the more number of AWS instances, so they don't cost much. Right? So that's the reason why like usually they suggest like to have like this kind of sorting on .NET side. Okay.
Okay. Yeah.
So there is one more case. I had an example. So with one of our code. So I'll just show you that example. Okay. So I'll just connect to our test database. Or I can show you here itself. Like let me delete all indexes. So we are clear with these indexes, right?
Yes.
Yeah.
So let me execute this. So here I don't have any other values. Okay, so I have only one index, like which is on ID column, right? So let me try to do small select star. Select star from users. Okay, so I'll just create a small index on date time. Okay, so let me, before actually doing that, so I'll just do one thing. Uh, star from So I'll just try to get only these ID values. Okay. So what I wanted to do is like, so I wanted to get only these ID values. So who's like creation date based on the creation date in the descending order. Okay. So in this case, we can see actually it is actually doing a clustered index scan. I think 1 second. This is not the right example. Cluster. Okay. So I'll take some range key value, which is somewhat less. So in this case, so what I wanted to show you is like, so basically it is actually doing a seek, and after doing a seek, so it is actually having like an extra operator, right? Sort operator.
Yeah.
Yeah. So you can see like it is actually sorting on creation date, right? So now let's execute the same thing on ID. So you can see here, like, so if you see both of these queries, so the first query, so it is actually taking only 24% of CPU for fetching this data. So how many rows do we have? Like we have approximately 10,000, 11,000 records, right? So just to fetch these 11,000 records, so it is actually taking this much of memory, CPU utilization. Whereas like the majority of time it is actually spending on sorting, right? So on what sorting it is actually doing? So it is actually doing a sort on creation date, right?
Yes.
Okay. So the same query, what I'm trying to do is like, so I'm just doing like less than operator, same query, but this time I'm just using ID descending. Okay. So you can see like the sort operator is not actually present in this case. So that is because the reason why it is actually not having a sort operator in this case is, so it is actually the data that is present in the leaf nodes of clustered index. So it is already in sorted manner, right?
Yes.
So it is not required to sort again on this ID value. So that's the reason why it is avoiding this sort operator. So in most of our cases, like, so I saw in most of our examples, so what we do is like, so in order to get this ID column, so what we do is like, so we try to get like, we try to query it on creation date to get like the latest date. So do you think like these two queries will yield different results?
Yes.
Same or different results?
Same result.
Same results.
Same results.
Yeah. So why it is same results? Because so the creation date is mostly like, I'm not sure in this Stack Overflow case. Usually like columns, some of these columns like creation date and then updated by updated date, and some of these are like timestamps. Okay. So whenever like we insert a record, so it actually inserts based on the timestamp. And also our identity, our ID column is identity column value, right? So when we have like incremented order, so 1, 2, 3, 4, so obviously these records, like, so these dates, so they will be also in the same order, right? And I don't think so, like, so it is like actually needed to do an order by creation date. So we, in that case, like we can make use of like just ID order. So any questions? Or like anyone like they don't agree with me or something like that?
No questions, Pranav.
Okay. Yeah. So usually like I'm hoping like people, whenever they try to write queries, so what I'm just assuming is like, so they'll also keep these operators, some of these operators like sort operators and everything in mind, and then they write their queries. Okay. So how they, so we saw like how this sort operators actually impact. So when in some cases like it is actually mandatory, like, so we cannot avoid these sort operators, so in those cases so it is okay. But in majority of these cases, like where we can avoid some of these operators, so we can rewrite those queries in a smart way. So that is the thing. Okay, so we covered like covering indexes, so we also covered like indexes on multiple columns. And then I wanted to show you like a few small demo, like till date, like we saw about these logical reads, right? So how these logical reads impact us, and then so you can how these logical reads are actually impacting us, right? So one logical read is nothing but like 8 KB pace. It is actually trying to read an 8 KB pace. Okay. So let me try to have another demo, and I'll show you what these read pages are. Okay. So I think like people who are following my previous session, so they know like what this DBCCI and Stack Overflow post statement does. So this will actually show us like the number of pages that are present in this clustered index, like post clustered index. So we have almost like 8,65,000. Yeah, 8,65,000 pages in our clustered index. Okay, so whenever we do like select star from post, so it is actually reading all this data from this clustered index. So before that, let me show you one small thing. Okay. So my SQL server, so right now it is actually consuming almost like so heavy. So it is almost like 10 GB. Very bad at maths. Let me calculate it. 1259. So it is actually consuming like 1 GB of data, right? So because like I have only index, so let me actually try to stop my SQL server. Just wanted to show you a small demo. So I'll just restart this SQL server instance. And in the background, like you can see, like, so it got restarted, right? The consumption is very less, like, so it is actually, so previously this is the amount of memory that is used. So now let me try to execute a small query. Okay, select star from post. Okay, So in the background, like you can see how the memory consumption actually goes up. So it is actually increasing. So my Stack Overflow database is almost like 10 GB database, and out of this 10 GB, like 7 GB is allocated for posts. So posts occupy almost like 7 GB of data, and users occupy approximately like 1 GB, I believe, like 8 GB, and other tables like they occupy remaining data. So when I'm actually doing this query, so let's start from post where last edited display name is equal to so and so, and I don't have any index on this particular last edited display name. So I'm just in this case, what is actually happening is it is actually going for clustered index scan. So it would almost like all, I think like, yeah. So you can see approximately this is almost equivalent to 7 GB of data. So in this case, what is actually happening? So when I'm executing this query, so this is actually fetching the reading data from my disk. So I have like all the data that is present in the disk. Right? Oh, just give me a second. So should have enabled the statistics I want. So I'll just restart it. So again, like my consumption, so it will drop. So it will drastically shop. I executed like set statistics I want, right? So in this demo, I mean, with this demo, like what I wanted to show you is like, so how the data is actually persisted in memory and how it actually helps us, like the persisted data. Like usually, like for some of these problems, what we saw is like, so whenever we execute the query for the first time, so we see like some delay. So some latency or some timeouts. And next time, like when we execute the same query, we'll get the results very fast. So what's the reason behind that? So I'm just going to show you that. So I think I'll stop it after this demo. Like I'll not take more time. So you can see my RAM consumption. So it is drastically getting increased. Okay. So again, like same amount of RAM, almost similar lines. And now we'll see our statistics IO on. So you can see like these are the logical reads, and we have approximately same number of read ahead reads. Okay, so usually you just remember this particular, I'll just paste it here. So now again, I'll execute the same query. So this time, like how much time it took? Like it took almost like 1 point. This is the time it took, right? So now I'll execute this query again. So this time I got it very fast. And also, this is the message from set statistics I want. Same number of scan counts, same number of almost like the logical counts, they differed a bit. Okay. So, and then you see this time like read ahead rows are 0. That is because so all my data is in memory. So maybe in next sessions, like we can see in tomorrow's session, what we'll do is like we'll explore a bit about this buffers and how does this query caches, query plan gets cached, and then all this information. Okay. So any questions till now?
Yeah, Pawan, one question.
Okay.
After executing that query for the first time, and if we insert a new row with the same get killer name, so that record won't be in cache, right? Then it should again scan the entire thing.
So when you actually insert a record also, so there are chances of the row that is getting inserted into the memory, like logical reads of the page. We'll see that in the next demo, Funny. Okay, so let's have it as a point. Okay, even I never explored that. So even like different where conditions also. So even if I do like select start from post, so or some different where conditions, so it does the same thing. Okay, so it actually reads all the memory. So because all my pages, approximately I have these many pages, right? 8 lakh pages. And also in this case, if you see, it is actually reading these many pages, like 8 lakh pages from the memory itself, like without any read ahead rows. Okay. Okay. Any other questions apart from this?
No, not from me.
Okay. So I think like I'm clear. So with this, like I almost covered like all those indexes. So what are all like different indexes, and then so when does an index seek happens, and then scan happens, and also covering indexes, and then indexes on multiple columns. Okay, so we'll see about these items. Like next session, what I'm planning to show you is like some of these memory aspects, how this memory, so query execution plan, how does a query actually gets cached, and also how the data is actually cached, how can we clear this data, some of these informations. Okay, and also I'll show you in the coming sessions, I'll also show you something related to some of these items. Okay, so cache related informations. Okay, so I think like I'm done for today's sessions. Any questions, like you can ping me offline.
Okay.
Yeah.
Okay.
Thank you guys.
Thank you.
Thank you.
And as soon as the recording is available, I'll upload it. All right.
Yeah, thank you.